So finally, we derive the formula PV power x equals to constant. Which process is this?
Polytropic.
Polytropic process. So once we have the PV power x equals to constant, we can go back and create some nice differential. So can write this as dp by p less x dv by v equals to 0.
Yeah.
Or I could have used dv power x minus 1 equals to constant. And therefore, I can also write dt by t plus x minus 1 dv by v equals to 0. Or I could have used t power x upon. And so I could have written x dt by t is 1 minus x. Oh, I think it is x minus 1. It is x minus 1, right? So x dt by t equals to x minus 1 dp by p. So these are the set of equations which you can come across. You should know how to write one into other in differential form, in normal form. So now we are going to assume that this is the polytropic process guiding equation, PV power x equals to constant. And we would like to derive the C value. So we know that dq equals to du plus dw. So nc dt is actually equals to how much, guys? ncv dt plus p dv, right?
Yes.
So what is C actually? Because that is my question. How to C is constant, but what is the value of C? So we can write C equals to Cv plus P d by N dt, right?
Yeah.
So this is the most important equation that you must understand and remember. Oh, why I'm writing 3, I don't know. Just for A. Now to write in a simpler form, I need a differential by the name dv by dt. Tell me, guys, from which of the following bracket square the dv by dt can be obtained?
The second one, sir.
And can you tell me what is dv by dt? It is minus v by t into x minus 1.
Yes, sir.
Yes.
All right. And now this is the equation B. So P by N and d by dt is how much? Minus V by. And if you look carefully, it is going to be really interesting. P by NT. Can you tell me what is P by NT?
R, sir.
Exactly. So what is C value? C minus R upon X minus 1, isn't it? But CV itself is R upon gamma minus 1. So C is actually R into and this is what you must remember. This is the most important relation. It is very easy to remember. R into 1 upon gamma minus 1 minus 1 upon X minus 1. X will come from the polytropic and gamma is the nature of gas, whether it's mono, di, or whatever. Is this clear, guys? Hello, hello, hello.
Yes, sir.
Yes.
Yes, sir.
So to get deeper into application, let me give you some examples. So you are supposed to express the C in terms of R itself. So someone tells you that in a process, P is directly proportional to T. That's not nice. Or someone says that okay, pressure PT square is constant. So this process, what do you think? Which kind of process it looks like? So of
Tropic.
course it is going to be polytropic, but always writing PV term. So P and plus T in terms of P. So PV equals to RT. So T equals to PV. Right, guys?
Yes, sir.
So what to get is P into P square. So PQ. But I always want P as a power 1. So we can write P V power how much? How much? Hello, hello, hello.
Sir, 2 by 3.
2/3.
And now you can compare. X is how much? You're done. Once you reach here, your job is really easy. It's done. X is known to you. Now, I will assume, let's say the gas is monoatomic gas. So I'm doing this experiment with monoatomic gas. So gamma, I again know. So I can clearly say what is the C value for this process? The C for the process is how much? R into 1 upon gamma minus 1 minus how much? 3 by 2 plus 3, right? Hello, hello.
Yes, sir.
Yes, sir.
So we get 639 by 2.
Sir,
Yes.
sir, in the second and third equation, it would just be like a constant, right, sir, the C?
See, for any polytropic process, you are going to get C always as constant. That was the assumption with which we started the derivation, right?
Sir, but since C is the molar heat capacity, like when we keep altering the equations without taking into account the other constants that we use, so it will be just some random constant, right, sir?
Yeah, I mean, of course, if you know the PV relation is given to you, so it is one particular polytropic process, not in general. This is one single process. This is one single actor. Okay.
Yes, sir.
For this guy, the C is 9 by 2R. If you are following this process, then the C of this process is bound to be 9 by 2R. Understood?
Yes, sir.
So it is constant. And of course, it is only for the process which I have written on the left. T square constant, right?
Yes, sir.
Any doubt in this?
No, sir.
Now the benefit is once you know the C, the dq is the easiest thing you can write. Dq is NC dt, that's it. So replace C here and they will give you moles, temperature change, and you can get the dq. So in polytropic process, we always calculate the C first. And because we know the C, we always write the dq. Okay. Hello guys, is this clear?
Yes, sir.
Yes.
Now,
Yes,
no,
sir.
no, no. We can always find the work done. So work done in polytropic. See, we know PV power X equals to constant. No need to think. You see, formula wise, the way PV gamma gave you the answer, the same answer should come here, isn't it? So can you write the answer is P1 V1 minus P2 V2 upon X minus 1, if you remember?
Yeah.
Yes, sir.
Yeah. No, it's on that page. Yeah. So the work done in any polytropic process is very easy. First, you find x, and once you have the x, you can write like this, or you may write nr t1 minus t2 x minus 1. So whatever is given, you can get the unknown. Okay. And we know how to find dq. In fact, I know everything now. So du is anyway universal. It has nothing to do with. So if you give me dt, I can find du, and I can use this and this to get work done directly. So we can also write w is. So it is always n c minus cv dt, right? This is the general formula. So for any polytropic process, the work is always n c minus cv into dt. Is this clear? No.
Clear.
Yes. So this is the crucial equation here. Now, what are the conditions for C to be positive and C to be negative? Because C we can write as 1 upon. Okay, is gamma always more than 1?
Yes, sir.
So tell me the range of x when C is positive. For what range of x C is positive? For what range of x C is negative? Tell me. For C to be positive, what all values of x can assume? Hello, hello. For C to be positive, what all values of x can assume? Gamma is
So if C is greater than, sorry, if C, I mean, X is less than gamma means it would be negative.
Pardon?
So if X is less than gamma, then C would be negative.
Yeah, if x less than gamma, C would be negative.
Yes, sir. And if it is positive means X should be greater than gamma.
That's it. Think more about it.
Okay, so.
So you all know domain and range question. You can solve here.
So,
Yeah.
sir, X should be less than 1 and greater than gamma.
Yeah.
Yes.
Very good. See, the moment you make x less than 1, the second term may become negative. So minus of negative is positive. And first term is anyway positive, right?
Yes, sir.
So C is bound to be positive. And if x is more than gamma, right?
Yes,
So
sir.
the range is how much? X belongs to minus infinity to 1 union isn't it?
Yes, sir.
And for X, I mean for C negative,
Sir, X should be between 1 and gamma.
correct. So for C to be negative, so it must be more than 1, first of all, but less than gamma. I hope this is clear to all of you guys. And these all are, you know what, error problems. Okay. Now, because we have already seen the celebrities, I'll show you that all are polytropic process. What is isobaric? P equals to constant, right? So
Yes, sir.
can I write PV power 0 equals to constant? So X is 0, isn't it?
Yes, sir.
So C will be R upon gamma minus 1 minus R upon 0 minus 1. Basically, it is CV plus R. Basically, it is CP. Oh, wow. That's the answer. For isobaric, it is CP, no?
Yes, sir.
Yes, sir.
That's a proof. It's correct. So isobaric is also polytropic, but it's a like kind of a celebrated actor, okay, or actress. Now, isochoric. V equals to constant. So P0 V equals to constant. So PV 1 by 0, or roughly we can say this is P infinite, or you can say undefined. What is X here? So C equals to CV minus R upon. Oh, that's correct. C must be CV, right? Isn't it?
Yes, sir.
Yes, sir.
Isothermal. Oh my God. C equals to, I mean, sorry. PV equals to X is 1. C equals to tends to infinity. Isn't it?
Yes, sir.
And that's logical. You can't change the temperature no matter how much you give the energy, because C is infinite. Which means the amount of energy required to raise the temperature by 1 degree is infinite. And we know that isothermal means temperature cannot rise or fall, isn't it?
Yes, sir.
No. And the last, adiabatic, what do you expect? The C must be, adiabatic means what? P power gamma constant. So X is here, gamma only, na? Correct?
Yes, sir.
Yes, sir.
So C will be 0. And that's it. We know that dq is NCGT because C is 0. So this is 0, which is the definition of adiabatic. For adiabatic process, C must be 0, isn't it?
Yes, sir.
Hello, hello, hello. So now I'll show you something more deeper. And that will reduce the burden of solving some challenging problem. If you do not know these tricks, it's very, very difficult. So if I plot a graph PV, how the isobaric will look like? So let's say I'm going from V1 to V2 in each case. So which process is this guy? Tell me.
Isobaric, sir.
Okay. Isochoric is of no use, but anyway, if you want to show, you can show. This is isochoric. And then we have two more processes. Isothermal. And the adiabatic will be how much? Below or above?
Below, sir.
So what is X here? If you remember, in the PV power X formula, for isobaric X is 0, isn't it? So do you guys realize this? No. Yes, maybe.
Yes, sir.
So if this is isobaric, this is, let's say this is isothermal. Let's say this is adiabatic. This is isochoric. All done. So this is X is how much?
Infinity, sir. Oh, sorry, this one is 1.
This one is 1. X is
Yes.
1, no? C is infinity. X is 1. And near X is how much?
Yes,
It means if you go from top to bottom, it is 0, 1, gamma. You can see the interval. So when C is positive, the answer was when X belongs to
minus infinity to 1, union gamma to infinity.
very good. So it should be between, I mean, it should be beyond gamma or before the 1, right?
Yes.
Okay, very good. So what is the value of C here in this region?
Negative.
greater than 0, sir.
And what is C here?
Less than 0, sir.
And what is C beyond this?
Again, greater than 0, sir.
This graph is the graph which you must remember if you want to solve the most challenging problem of JEE Advanced. This graph one must remember. Now, once you remember this graph, I can tell you something. If I plot a random graph, something like this, some random graph, some, let's say, this process is called the Mark Zuckerberg process, some random name. If I draw a graph like this, let's say this is the Elon Musk process. So let's call this as process 1, process 2, process 3, because these videos will go online, so maybe some copyright can come. In the last video, copyright came because some music was playing behind and it got captured in the video. And I saw there's a copyright action on me. And it was because of the music coming from behind. Anyway, that's interesting. Now tell me, in the 3 process, you can clearly see the process if you get x which is between 0 and 1, you're going to get definitely a C positive, right? So if temperature increases, let's say in a process temperature increases. So let's say if delta T is positive, if delta T is positive, then among process P1, P2 and P3, which will absorb heat and which process will release heat. Tell me. So we all know the relation dq equals to nc dt. So tell me guys, if dt is positive, then heat will be absorbed when C is
Positive, sir.
positive. So when C is positive, it means any process with positive C will absorb heat upon heating. Any process with negative C will release heat upon heating. It's very interesting. So theoretically, it is possible. So I'll put it as a note. Any process in which any polytropic process, or in fact solution, any polytropic process in which C is positive upon heating, it will absorb heat upon cooling, it will release heat. When C is negative, upon cooling, upon heating, it will release heat, and upon cooling, it will absorb it. So in physics, it is not necessary that every time you are raising the temperature, heat is absorbed by the system. So theoretically, anything is possible. So you have to check the C value. Okay. Is this clear, guys?
Yes, sir.
Okay. Some confusing question. There is a gas which undergoes a process such as PV power 5/3 is constant. Gas is diatomic. Is the process polytropic or adiabatic?
Polytropic, sir.
But if the gas is monatomic, then
Adiabatic, sir.
yeah.
And both, sir.
I mean, no, you just say separately only. I mean, of course, I have related, but if the gas is monatomic, then the power will match with gamma, right?
Yes, sir.
But luckily here, gamma is actually
7/4.
so gamma and the power is not matching, so it is polytropic. So here X is how much? Is this clear, guys?
Yes.
So the C will be how much? R upon gamma minus 1.
Yep.
X minus 1. So this could be a confusing problem. That's why I have given this question. So this is it is R. Correct? So here the R C itself is R. So dq equals to NC dt, which is NR dt. Nice. All right. I hope this question is clear.
Yes.
Okay. What else I can teach here? Yeah, this is again famous question. So see, every process is not polytropic. This is what I said. But you think that no, every process, I mean, any process which is not the regular one are polytropic. So I'll show you a question in which this process is actually not polytropic. It is a variable process. I mean, the process is having no, I mean, well-defined meaning actually. So the problem which will come across is again very famous. And again, this problem you will see in almost every paper, maybe at least once they ask this question for sure. So let's say if I give you PV graph and I plot a graph like this, tell me which process you can correlate with. Is it isobaric, isochoric, adiabatic, or polytropic? Okay, is it possible for this to be polytropic? Can this process be polytropic?
Yes, sir.
Yeah, it is possible.
Yes, sir.
But you do not know, right? Here, the relationship is not in this format, right? So this process cannot be polytropic because it's a straight line. It is a straight line, right?
Yes, sir.
So this cannot be because this is the straight line with intercept also. So this is not going to become P per X format by any value of X, right? So anyway, this is some random process. It doesn't fall into any category of process which you know so far. So when you come across such process,
Sir, but here dp by dv is equal to constant, right, sir?
yeah, fine. So in the polytropic process, is it constant?
Mm,
No, because it will be having formula dp by dv equals to minus x p by v. Try to recall the adiabatic we have derived, right?
yes, sir.
So it is function of p also, v also, x also. Is it constant? No.
Yes, sir.
Anyway, guys, tell me what will be the okay? How to solve question like this? I mean, there's nothing given. It's really sad. Nothing is given. So what you can do? One thing you can find for sure is, of course, area under the graph, which is the work, right? But apart from work, can you find anything else?
No, sir.
So
Sir, we just make the equation and then try to solve it.
exactly. So you're supposed to first find the equation. Can you find the equation of this graph? Can you find the equation of this line?
Yes, sir. 1 minute.
It's a simple straight line, so you can use the straight line relation.
Yes.
So anyone getting the answer for the equation line? It's a 2-point form. You can find the answer, right?
The same. So like the fully simplified one or
Yeah,
the
I mean,
equation where like this?
P equals to, I want P equals to everything.
Okay, so
Yeah.
sir, I'm getting P is equal to P naught by 2 V naught into V plus 3 P naught by 2.
Just a moment. P equals to,
Sir, P naught by 2 V naught into V plus 3 P naught by 2.
so anybody else getting the same answer?
Yes.
Same answer?
Yes.
I don't think this is the right answer. The intercept should be more than 2 P naught, isn't it?
1, 2, 3.
I can see that the intercept is much above the 2 P naught.
Yeah.
So this is anyway wrong answer. Y equals to mx plus c, c is less than 2 P naught. Okay, do it once again. So what is the coordinate of this point? V naught, comma,
2 P naught.
Sir, yes, so the slope is negative. So it will be 5 P naught by 2 would be the constant and minus P naught by 2 V naught into V would be the slope. Sir.
so now if you add the 2 point from P is coming how much?
Sir, minus P naught by 2 V naught into V.
Yes. And what is the intercept?
Sir, plus 5 P naught by 2.
Now that makes sense, right? Because it should be more than 2 P naught, isn't it?
Yes. Sir.
So are you guys getting the same answer? Tanishi, are you getting the answer? Same answer?
Just a second. I think I'm messing up my constant. Just a second.
See, this is the equation of straight line. Come on, your JEE-Mains is coming. This is a straight line equation. You're not getting it correct. Everyone, think about it.
Sorry, sir, it was a silly mistake.
It should not be. I mean, such silly mistake is not acceptable.
Yes. Sir.
Yes, sir.
Okay, so now this is the equation. Now, let me tell you. Do you remember the formula of C? C equals to how much? CV plus P d by N dt, right? If you remember, this was the actual formula of C.
Yes. Sir.
Now, in this formula, it is not a polytropic that I can replace dv by dt equals to minus v by t x minus 1. That is not possible. So I have to first find the v and t relation to solve any question of C. If I want to find C, I have to first need to know the VT relation. What is the relation here? PV relation. So we know PV question RT, so we can add P question nRT by V, isn't it? So from here, can we write like this? Tell me guys, yes or no?
Yes, sir.
nRT is how much? And this question is very crucial. I mean, you will come across this question many times. So T you got this answer. Okay. Now, because T is a function of V, we can find dt by dV easily. I will invert it later on. So if you differentiate, what you will get? And now, because I know this equation, I know this equation, you know, you can substitute the answer. So finally, C equals to CV plus, of course, P by M, and dV by dt is how much? 1 upon you can take something from them. Yeah, we can me not by 2, I can take one. And minus 2V by V naught plus. So anyway, it's very, very bad value, but this is for you to realize. So I got the answer. Let's substitute value. How much is the answer? 2n RV naught. 2n so C turns out to be CV plus PRV naught. And the P itself we got, what is P?
So
Yeah.
I think you missed 2 in the above step.
Yes. Correct. So now you can see the C depends on what? It is depending on volume, right? As V will change, C will change continuously. So here the C is constant or variable. You can see clearly. Here C is variable. And this is what you just need to know, nothing else. Okay. So this is the question you can further write. No one will ask you, don't worry at all. I always, every year I solve this question just to demonstrate this fact. Okay, finally, this is the expression, and you can see now this answer clearly says that. Yes, tell me.
Sir, the P naught in the numerator.
Will come here. Okay. Correct. So what you can see here, the answer, the C is variable. So C means sometimes C can be positive, sometimes C can be negative. So in the process, sometimes it is absorbing, sometimes it is releasing as well. Okay. Now, while it is absorbing, the temperature will grow, isn't it? So look at this problem. I mean, how much you got a temperature relation T equals to, or how much you got dT by dV you got? So dT by dV we got how much? 1 by E naught by 2 NR. Five V naught minus 2V upon V naught, right? No, no, yes. So you can clearly see, because it's a T is a function of V, and in fact, I mean, this is not required. You can see that T is a function of V. Which function is this? A quadratic, and the coefficient of V square is negative, so it is an inverted parabola. Do you realize this?
Yes.
So this is a very famous answer. This is inverted parabola. So we can find the T max. So also for maximum temperature in the process, you can get this to 0, which will give you the answer 5 V naught equals to 2V, which means V is 2.5 V naught. At 2.5 V naught, the temperature is going to be maximum. In fact, you will also come across question in which they will ask you graph. Plot the graph between T versus V. So when V is so V is varying from where to where? V naught to 3 V naught. And our answer is 2.5, right? So somewhere here, the temperature is going to be maximum. So graph will be like this. But we cannot plot this graph because our V is starting from here. This is your graph. And the maximum temperature will get at this. And this is the process. You can clearly see between V naught to 2.5 V naught, basically the C is positive. And you can also say it from here, no? What you can see? When dt by, or when d, this is positive, this term is positive only when 5 V naught is less than, I'm sorry, more than 2V, right? Which simply means before this value, C is positive. Beyond this value, C is negative. So here, up to this point, heat will be absorbed. But here, released. Okay. Upon increasing temperature, not, I mean, this. Sorry, this is again incorrect. Yeah, here this is heat absorb is correct. But because here C is negative, which means upon decrease of temperature from, because this is the T max, no? This is T max. So beyond this point, temperature is decreasing, guys, isn't it?
Yes, sir.
And C is negative.
Yes, sir.
So heat is again
Positive.
absorbed only.
Yes, sir.
So you can see very interesting that before that T max, it is absorbing because C is positive. Why? Because temperature is increasing in this process. Beyond that, temperature is decreasing, C is negative, so again heat is absorbed. Very interesting. So question will be asked that in the process, is the heat continuously absorbing? Is the heat first absorbed then released? Is the heat first released then absorbed, and so many things? So here the answer is, it is continuously being absorbed. Is this clear? Maybe.
Yes, sir.
So these are like some challenging problem which you came across. The last thing, but not the least, from the first law is, and then I'll stop the lecture today. Second law I'll take tomorrow for 1 hour, and for the next 2 hours I will solve the PYQs. So the last thing called efficiency of cyclic process. Yes, please leave. It's only 5 minutes left. So this is called efficiency of when you are solving question of efficiency. So they will give you generally some shape, some process. Yeah, leave. Those who want to leave, because I now I got one more idea, which I'll discuss and then leave. So we have PV graph. Let's see if I do some nice simple process like this. So the first process is isobaric, and we know in isobaric process, as you go from left to right, the volume is increasing, so the temperature is also increasing, so heat is absorbed. So here the heat is absorbed, but here the heat will be released, and from B to C you can see the pressure is decreasing, so heat is released, and this again heat is. So the idea is efficiency. When we find the efficiency, it is defined as total work done upon total heat absorbed, which means whenever they give you cyclic process, what you need to do is you find the dq for each process separately, check the sign. You may get some dq positive, you will get some dq negative. The positive dq is called the heat absorbed, so you have to only put the positive dq in the denominator, and the work you have to put in the numerator. Work is easy, area under the graph. But in the denominator, you have to write the only the positive value. Okay. Understood. So sum of all positive DQs. That's it. You can multiply by 100 to write the percentage efficiency.
Sir, what about the negative value?
Negative is release. So this is, see, I am giving you money to perform work. If you are taking my money, so I will be only concerned with what you have taken from me, right?
Yes, sir.
And then I will check how much you perform the work. That's it. Now, if the system is releasing, it means it is like kind of not going to do anything. The release means it is maybe consuming its own internal energy, which we don't know.
Yes, sir.
So I'm only concerned about what I have given and how much work you converted from the investment, because that is the purpose of cyclic process. We are engineers. We want that your engine should do the work, and you will give the energy required. Okay.
Yes.
All right. So many has left. Let me also stop here only. So in the PYQs, the rest of the thing we can do in the PYQs. The last thing which was left is called the conversion of graph. Like you will be given PV graph and you're supposed to convert PT, VT, and so on. Okay. So please remind me in the next lecture. I'll start with conversion of graph. Most of the questions that you will possibly come across, I have discussed. These are questions. Theoretically, it's a very small chapter. So if you read now PYQs, you will come to know that most of the questions are really easy, you can solve. Okay. All right, guys. Bye and take care. See you in the next lecture. Tomorrow, I'll take a night class again and we'll finish everything.
Thank you, sir.
Thank you, sir. Bye, sir.
Bye. Good night.
Good night, sir.